Okay, this is a review for chapter 10 and chapter 5. And so I'm going to go ahead with that. I'm going to work through some of the reviews. So I just wanted to remind you of the rules for chapter 10. And these, I think, were the notes that I had. So in addition, if you're adding two numbers and the signs are the same, two pluses or two negative numbers, then you add the numbers, like 7 and 4 makes 11. But in the second problem, you add 5 and 9 makes 14. But when they're both negative, it stays negative. So it's like, -5, -9, you're getting lower and lower. So that the first set of rules has to do with if the two numbers have the same sign, both plus or both minus. Now, if they have opposite signs and it's still addition, like this one, then you actually subtract the two absolute values. So you would take 14, take away 12 is 2. But the sign goes to whichever number has the highest value in absolute value. So the minus wins because it's bigger. So it ends up being -2. So opposite signs, addition, subtract the two numbers. So you would go 14, take away 12, do it in the, with a big number on top. And then the sign would go to whichever number is the larger one. So that's basically what it says. So if you had these two, -7 plus 12, you have to subtract 12, take away 7, which is 5, but the positive one is the bigger one. So it ends up being +5. So what's different about subtraction is we're doing everything that's opposite of addition. And so one rule that will work is to add the opposite of the second number. So for instance, with this little problem, which you can already tell what it's going to be, you copy the first number, you change the subtract sign to add, and the second number goes to its opposite. So this now is addition, and then it goes back to addition rules. These two are opposite signs, so you subtract them. 8 take away 5 is 3. The larger one is the positive 8, and so it ends up being +3. So these were just examples of that. So we'll have to remember subtraction is converted to addition. And then multiply and divide, it's so nice because the rules are identical for both. And so when you have two positives, a positive times a positive, it's positive. And what's interesting is a negative times a negative is a positive. So what happens here with these two is that if one of them is positive and one of them is negative, one negative multiplied makes it negative. And it doesn't matter if it's the first one or the second one negative. So 5 times 3 is 15, but one negative made it negative. So the exact same rules go to divide. So actually multiply and divide are the easiest. Add and subtract requires a little bit of thinking, but not so much. So those were the notes we had when we did this. And when we first went over it. So what I'm going to do there. So this is the chapter 10 review. And so we're going to do as many of these as we can. We may skip some. The first symbol, I don't know if you can see where I'm making my mark, is less than. The second one is greater than. So when you have to place one of those two symbols between -2 and -24, well, -24 is much lower. So -2 is actually greater. And so we would literally have to say greater than. And there is a key on your, okay, it's greater than, because it's, you know, this is lower. Let's see, okay. So this one here, the two marks that are straight up and down are absolute value. So that means just take the number and forget about the sign. So this would be 29. This is -10. 29 is clearly greater. And so that's the correct symbol. So it seems like they have a pair of problems and then, okay. So I think I can skip every other problem and cover all the topics, I think. So with this first problem, you have to do absolute value first. So the absolute value of -69 is just plain 69. But then the sign in front makes it negative. So this one ends up being negative. What's different about this second one, there's no absolute value. It's just the opposite of a negative. Or it's like the multiplication where two negatives make it positive. This one ends up being positive. So in the first case, we had to deal with the absolute value first, and it became positive, or just 69. Then one more minus made it negative. But in this case, the two negatives make it positive. Let me see if I can do it this way and skip it like that. Okay, I saw a few problems like this, and so Rosa is snorkeling, so she's in the water, and so it's sort of like below the water level. So we're interpreting that as like a negative number. So she is 4.6 feet below the surface. So represent that. That would have to be negative 4.6. Does that work for everybody?
Yes.
Yeah, because it's below. If she goes down another 7.2, then she's going even more negative. And so what would that be? Well, and if we need to go to paper, just let me know. But we're at -4.6. And then we're going to drop some more. And so the dropping some more is also negative 7.2. So the two signs are both negative, and so we're getting lower and lower. So we add the two numbers, which is 11.8. It would have to be negative because she's going lower and lower. Does that make sense? That's a point. Or are they going to mark me wrong? Okay, so she kept diving down, so that made it lower and lower. Have I made this large enough for most people? I guess that's as big as it
Yes.
gets.
Yes.
Yeah, I think it's as big as it gets. Okay, here's a perfect little example of what we really just did. It's an addition problem, and it actually says so. It's a -8.2 and a -5.3. So the whole job is, can you add 8.2 and 5.3? So I'm going to add it for you just to be nice. And so it's 13.5, but the two negatives make it more and more negative. It's like borrowing money and borrowing some more, and you're basically in the negative range. So if you know, water doesn't work it or temperature doesn't work it, this does it. It's like a minus and another minus, we're further minus. And so the signs were the same, we added them, called it negative. Okay, this one here is really the same thing, but it's written slightly differently. But this is this, we might as well think of this as money if we want to. It's -6.03, -1.2. So it's a negative and another negative, so we're going down and down. So we end up adding them. The negative 1.2 could be written as negative 1.20, just so that things line up. And so I'm getting negative 7.23. Now, at any point in time, if you want to see this on paper, let me know. So all I did was add those two numbers. Let's go down to this one. Okay, we have to read it. I hate reading. On Wednesday, the temperature reached a high of 23 degrees above zero. That night, it dropped 3 degrees. It dropped to 3 below. So be careful about this sentence. That night, it dropped to 3 degrees below zero. So it's at -3. What is the difference? I don't know where this was. I guess maybe it's a reasonable thing. It was below zero to start with, or below freezing, and then it dropped below zero. So you might, technically this is a subtract. So it's actually 23 subtract -3. And I'm going to quickly go to paper. So it's this one. So here's zero. This is the thermometer. And if you were at 23 to start with, that was the morning temperature, but then it's dropping to -3. Can you see that the difference is more than 23 degrees? It's the 23 degrees plus the 3 more to go below zero. Can you see it's going to be 26? So when they say difference, it's a subtract problem. So it's 23 subtract -3. And I think you might remember that I showed you this. When you subtract a negative, it's the same as plus. So it's 23 plus 3. It's actually 26 degrees. The 23 to get to zero and the 3 more to go below zero. So you might have done it. You might have done it this way, but you might have, thought of it like a thermometer. Let's see if they like that answer. I'm going to put it in 26. And if we're ever wrong, well, we'll try again. Oh, they like that. Is that okay? Simplify as much as possible by changing all the subtraction to adding and so on and so forth. Okay, this is mostly a subtract problem, but every last one, well, the first number is positive, and I would write it first, but we've got to get a common denominator. 1/5 subtract 1/6 subtract 1/7. Anybody idea how what the common denominator would be? This might be more trouble than it's worth. This is prime and this is prime. 5 and 7 are prime. And this is actually 2 times 3. We end up needing all of those numbers. 5 times 6 times 7. We need them all for the common denominator. This is 30 times 7, it's 210. So all of these have to go into 210. I'm not crazy about this problem. So it's 5 times 6 times 7 is 210. So in this first number, it's 5 times what? And it's actually times 5 goes into this 42 times. I don't like this problem, but I'm going to finish it. This is 42 over 210. This one is 6, needs to go into 210. And so if we already have 6, the multiplier number is 5 times 7, 35. Do not panic. I'm not going to put this on the test. But this is 35. And then finally, the last one is 7. The missing factor is 30. So this is 1 times 30 is 30. So now, this was more trouble than it was worth. But what we need to do is remember that this one was negative and this one was negative. I'm going to put my negative here so I can see it. So the denominator is 210. But the real job here, and this is why I kind of rushed through this, is we have to add this number to this number to this number and put it right there. And so what would that be? Well, it'd be 42 plus negative 35 plus negative 30. Now, one thing you can do is put your negatives together because you just add them. And so 35 and 30 make 65, but that's negative. And then it's positive 42. Now this one, this is a plus and this is a minus. You end up having to subtract them. Let me try to do it. 65 and 42, 23. Positive or negative 23 for these two?
Negative.
Correct. So this is the final answer. Now, I know why this problem became so annoying, and I think it's because some of the problems are computer generated and nobody actually did them by hand. To see, this was like a bit too much, but that's what happened. But I guess the real work, what we're really interested in was this, and this, and this, when you had to add 3 numbers. It doesn't hurt to add the 2 negatives together because that's easy. You just add them, call it negative. This was where the signs were opposite. We subtracted them, which I did down here, but it had to go negative because it was the negative that was the bigger one. Okay. Well, it's not too happy. If I can spot a problem like that, I'll just axe it. Okay. Let's see, what else? That one. Let's do 15. Okay. All right. It says product, and basically the way the problem is written, it implies that you multiply the 2. So you get out your pencil and go 1.8 or pen and multiply 1.9. And so I'm going to quickly do that. Now, the thing to remember here, I'm going to go to paper, but basically there's 1 negative multiplied by a second negative. 2 negatives make the answer positive. So we're going to call this positive no matter what. But I'm going to show you. So all I did was multiply these 2. This was 72 carries 7. Oh, wait, I made a mistake. 72 carriers 7. This is 9 and 7 is 16. This is I'm getting 342. Anybody disagree?
No, I
Okay,
used my calculator, so that's,
so that's good. So at this point in time, this was what we learned in the decimal chapter, that there were two decimal places. That was my mistake. So it's 1, 2. So it's 3.42. Okay. The two negatives, this was negative and that was negative, end up being positive. So unless there was some sort of rule about rounding, and I'll go back and I'll look. No round, there was no thing. So I'm going to just put in the full answer, 3.42. And if they ever don't like our answer, we'll find out. But they did. That was good. Let's do 17. Okay. Now, it's 3 times 7 times 2. So 3 times 7 is 21. And 21 times 2 is what? 42, right? But guess what? That's going to be marked wrong. And the reason is because two negatives, the first two negatives made it positive. Then this positive times the third negative makes it negative. Any question about that? So if you did them inch by inch, you would go -3 times -7. That would have been positive 21. Then positive times a negative would end up being negative. So there's two parts to this answer, the number answer and the sign. And so the sign is just as important as the number. Okay. Order of operation with some negatives in here. I think we can do this without going to paper. 5 minus 4 is in parentheses, that's 1. 6 times 1 is 6. So now the whole problem is -7 plus 6. Anybody want to venture an answer? After the plus sign, it's just equal to 6. 6 times 1 is 6. So we're adding, but the two signs are opposite. It's a -7 and a +6. Does anybody want to see paper, or does this make sense?
is it just one?
It's just one, but what kind of one?
Negative?
It is negative. Because the 7 is negative, the 6 is positive, so the 7 wins. Right? There's more negative than there's positive.
No.
It's just like if you spent more money than you had. Does that work for you?
Yeah.
Then you're negative. Yeah, if money works when we're going to do money. Okay. These might get out of control. Find the product. Okay, so notice they're going to multiply these three numbers, a 7, a 6, and a 1. So that's going to be 42, right? Because multiplying by 1 doesn't change it. So it's a 7 times a 6 times a 1. But this, we did this already. Product means multiply. We can't forget that. But the first two negatives made it positive. Then positive times a negative makes it what? 1 positive multiplied by 1 negative. What is it?
Negative.
It's negative. So in the end, 1 negative is negative. In a multiplication, 1 negative is negative, 2 negatives is positive. And if somebody would venture, 3 negatives is negative again. And that's your answer. So the number part wasn't that bad. It was just figuring out the sign. I think I would try this one. Okay. So in order to do a fraction where there's steps to do, you need to do the steps first and then see what you can do from there. So the numerator, 2 times -7, positive times the negative is a -14. Okay. The bottom, the denominator is 9 take away 2 is 7. That's a +7. So if you're writing down, this is -14 over +7. Same rules as multiply. So it's 1 negative, means this answer will be negative. And 14 divided by 7 is 2. So what I'm doing is I'm teaching you by you're listening. Now, people, some people have to see it, some people have to hear it, and others have to write it. But I'm hoping you're writing these down regardless. And so 14 over 7 is 2. 1 negative makes it negative. Uh-oh. Bad vision. There it is. Okay. How's that? So I don't know if this last one's worth doing, but I'm going to look at it. I'm not going to do it. Okay. So let's do chapter 5. How's our time? Okay, we're okay. 25 questions as well. So if anybody at any point in time needs to see it on paper, then let me know straight away while we still have the problem going. But if we don't need it, we'll just write this and then you can look at this later. This first problem is ratio, and the first number is 30 and the second number is 75. So you take 30 on the top and 75 on the bottom, but you've got to reduce it. Now they both reduce by 5 because one ends in 0, the other ends in 75. And so that's one way to do it. So we would divide 30 by 5 and we get 6 on top. And we would divide 75 by 5, and I'm going to do it 1, 15. Now, I've got this down to 6 over 15, but I don't think they're going to like it. I got it 6 divided by 15. Okay. Now, I'm going to show you, you know what happens when you try to submit the wrong answer. They didn't like it, did they? And then sometimes they give you a little explanation about why they didn't like it. And the first thing they said was enter this in as a reduced fraction. So 6 over 15 is not reduced. It's correct in one sense, but it's not reduced because both of those numbers can be divided again. And the again part would be they would both divide by 3. So 6 is really 3 times 2, and 15 is really 3 times 5. So if you do that, the 3's cancel and you're left with 2/5. Does anybody want to see it? So I did it intentionally halfway, but then you get to fix it. Because they told you what wasn't quite right. This one here, maybe I'll do on paper, 2 2/5, the ratio, and 3 3/5. So you have to divide them, and we did this before. Back in the fraction chapter. So it was ratio of this number to that number. It's this divided by that. There's 2 steps to make this right. The first step is to turn them both into proper fractions. The book calls them improper, but I think they're very good. So 5 times 2 is 10. 10 and 2 is 12 over 5. We're still in the division. 3 times 5 is 15. 15 and 3 is 18 over 5. This is so much better, but not right. This division of fractions needs to be converted to multiply. So the first number is copied. This is similar to add some of the adding things we've done. This goes to multiply, and this goes to its reciprocal. Do you remember that? So this is 5 over 18. Well, this is the problem we're going to deal with, and those 2 5s are going to get rid of. Now 12 and 18 can be simplified some more, and so it depends on how you cancel. They both are even, so they both divide by 2 for sure. Maybe they divide by more than 2. In fact, they both divide by 6. And so depending on how you do it, this one is 6 times 2. This one is 6 times 3. And these were canceled already, so I'm just going to ignore them. So the 6's actually cancel out. And in the end, there's your simple little answer. But that was the problem, that the 5s canceled easy, but the 12 and the 18, you had to see what might go into them. And they both divided by 2, but the more I thought about it, they both divided by 3, which means they both divide by 6. So this is 6 times 2, and this one's 6 times 3. And so that's what we did, and that's how we, and you could do it slightly differently, but as long as you come up with 2/3. Questions? So see, they're forcing us to think back at our fractions, like it or not. You know what I'm saying. What was the answer? 2/3, wasn't it? I'm gonna slap it in there. Make sure we're still thinking correctly. Yeah. So here's 5. Okay, we were doing some of these in class yesterday. Write the ratio of 1.6 to 10. So I wrote a fraction on my paper, 1.6 over 10. Now, we don't like decimals inside of fractions, and so we need to move that decimal over one place, which is the same as multiplying by 10. So if I multiply the 1.6 by 10, I get 16. I do the same with 10. I move it over one place, and I have to add a 0. And so the problem becomes 16 over 100. Any question? Now, will that give me the right answer, or are they going to mark me wrong?
It's not reduced.
It's not reduced. 16 over 100, they're both even, so at least they divide by 2. But I think even better than 2, they both divide by 4. So 16 divided by 4 is 4 on top. 100 divided by 4, think of money, is 25. So the answer ends up being 4 over 25. Okay. Now, nobody's speaking up, so I think either you're happy or you're not willing to speak up.
I'm happy.
I have one happy. Okay.
I was actually gonna let you know, I'm headed to my next class, so I will have to leave here pretty soon.
Okay, that's fine. I'll
But thank you.
still recording, so we're good.
Great.
So this one here, I have to read it. So the flow of water from a faucet can fill 4 gallons in 32 seconds. Okay, that's the first sentence. So I just kind of wrote that down. Give the ratio. This is where the instructions are right here in the second sentence. Give the ratio of gallons to seconds. Reduced. So gallons is 4 and seconds is 32. So get the order just the way they asked for it. It's right here. Gallons first, 4, seconds second. So it's 4/32. You've got to divide both of them by 4. 4 divides 4 once, 32 divides by 4, 8. So it's 1/8. Well, that's the answer they're going to give it. So let's see if that makes them happy. Oh, they're still happy. Okay. The whole trick is the sentence, who cares? Find the instruction, number 9. Okay. So the gas tank can hold 60 liters. I'm going to write that down just in case I need it. On a full tank of gas, the car will travel 325 miles. Okay. So what is the mileage, miles per liter? Round to 2 places, which tells me it's not going to come out even. So miles first. So from my fraction, I have 325. And liters second, 60. And because I need some time here, 325 divided by 60. Whoops. 325 divided by 60. Answer.
Could you do the paper?
I'm using a calculator. 5.41, a bunch of 6s. So I do not mind you using a calculator for these problems like this. I've got to fix my window. So it's miles per liter. So I put miles on top and liters on the bottom. I hit the calculator. Now, what was the rounding instruction? It was 2 places, wasn't it? Or did anybody notice how many places? I thought it was 2. Did anybody? Was anybody paying attention?
Yes, I think it was 2.
I'm going to look real fast. 2, round, 2 places. So 5.41 with the 6 after it is going to be what rounding? There it is. You tell me. I've got to fix. The sun is coming in so bright I can't see what I'm doing. 5 point what?
2.
42 is right. Okay. Is that better? I don't know if it's better for you, but it's definitely better for me. I couldn't see. So that's 5.42. Right? Because the 6 makes the 2 go up 1. Okay. What was it? 5.42. Okay. They're happy with us. We're happy. 11. Okay. 16-ounce package cost $1.11. Give the unit price in cents per ounce, round to the nearest tenth of a cent. Okay, there's a couple of possibilities for having trouble here. The first possibility is this is in dollars, $1.11, and they're asking it for in cents. Now we've got ounces, 16 ounces. So the instructions are saying cents per ounce right there. So the cents, I'm going to put it $1.11. And the ounces are 16. And then we'll talk about getting it into what the way they want it. Because honestly, I did this with somebody else. So this was the cost. It wasn't in cents, it's actually in dollars right now. And so I'm going to use a calculator on this, 1.11 divided by 16. So what I get is 0.304992. That's what the calculator is saying. Now, this is still in dollars. So this is like, roughly speaking, 30 cents. And so to get it into cents, you've got to move the decimal, shift it over 2 places. So this is 30.4992 cents. So this was in dollars, 0.30. This was in cents, 30. Now that we have it in cents, the instructions were round it to the nearest tenth of a cent. So once it's in cents, we can do that, and that would be rounding there. What's the answer? 30 point what?
5.
5. And the cents were already, so you just have to put that number in. I think that's probably the easier way to go, but the fact that this was in dollars and they wanted it in cents, somewhere along the line we have to shift, and I decided to shift it at this point. Once it was in cents, then I was allowed to round it. And so that is the way the answer turns out. That's a little bit tricky. People mess that up. Okay. So what was the answer, P's? 30.5? I think that was what it was. Okay. Uh-oh. Did I? What happened? Enter as a fraction or an exact decimal. Wait a minute. Cents per ounce. Let me recheck my calculator. 1.11 divided by 16, right? Ah, I entered it wrong on the calculator. It's 0.069375. For some reason, I typed it wrong. Well, that's a clear indication something went wrong. So what do we need to do? We need to try again. So we did try again. When I divided it, I got this one. This is still in dollars. To get it into cents, you have to move the decimal 2 to the right. So that would be 6.9375 cents. Now we should be able to round it. And so the 3 doesn't make this change, and so the answer should be. I'm going to go back and see if that's the correct answer, okay? Did anybody do it on the calculator?
Yes, I got the same.
Okay, so there was an error when I did it the first time. Okay, let me know as soon as you see the error. So they didn't like that answer one bit, so we're gonna try again. 6.9. And if not, obviously I'm too tired to do this. Oh, okay. Okay, I bet we bounce back. Do you remember this? This is what we did in class yesterday. It's already set up. It's a proportion, which is what it is. Two fractions equal. One of the numbers is missing, and so the whole job is to find the missing number. So you cross multiply. And so what would that be? That would be 1 times 13 is just 13, right?
Yes,
N times
8
8,
times.
and I'm going to call it 8n. Now you find the letter, whichever side it's on, and the number next to it. And what I have is 8 times n. So
Mhm.
I have to divide both sides by 8, divide both sides by 8. Somebody asked me, so n is 13 over 8. And you can leave it like that. They don't make you like that, see? 13 over 8. You can leave it and get it right. So you don't need to make a mixed number. Unless you just want to. This is the same thing, just with fractions. How annoying. So we're going to go, so it's ready to go. So it's n times 1/3, the diagonal going down. So I'm going to call it 1/3 times n equals, the other diagonal would be 14 times 1/6. Now, 14 times 1/6 is 14 over 1 times 1 over 6. And I'm going to reduce
On the
that.
paper?
You want to see paper?
Yeah.
Yes.
I think so. I don't know how they did that. I mean, I know ways to do it, but I'm trying to remember how they had us do it.
Okay.
Okay. So I have 1/3 multiplied by n equals 14 times 1 over 6. Okay, that was the problem. What I was going to do first is make this simpler, get this straightened out. And so I put 14 over 1 to help. And so this is actually 2 by 7. And this is actually 2 by 3. And so either you do it like I'm doing it, or you divide both of them by 2. So your answer ends up being 7 over 3. 7 times 1 is 7. 1 times 3 is 3. So this is 1/3 times n is 7/3. Now, I don't believe this is part of solving equations. And I'm not sure they showed you what to do, but I'm convinced you could guess the correct number. What
So
would it
when
be?
you did the both line number, the 1 over 6, 1, 3, how you did that one?
Yeah, so 6 is it really 2 times 3?
Mm-hmm.
And 14 is really 2 by 7.
Mm-hmm.
What I did was just take out a pair of 2s, a 2 on top with a 2 on the bottom. And then I multiplied across. 7 times 1 is 7, and 1 times 3 is 3. So that's how I got 7 over 3. Now, other people learn to cancel like this. So 2 into 6 is 3, 2 into this is 7. Same thing. It just depends on how you learned.
So the other place is 1 over 6 and 1 over 3. How you put together that one is tricky. So you multiply 9 n plus times 1 over 3.
Yeah, I'm trying to look at the problem. Let me see. Let me just move this down so I can see it. The original problem was n over 14 equals 1/6 divided by 1/3. Okay,
Mhm.
let me bring this back. I just cheated. That was the original problem. So I
Okay.
multiplied this way. It was all ready to solve. So I multiplied n times that and got 1/3 times n. And then I multiplied the other direction, 14 times 1/6. Remember, these two multiplications are equal.
Mm.
And this was a bit of a mess. So we fixed it to 7/3. We still have this. 1/3 times a number is 7/3. Can anybody guess what the number has to be?
7.
It has to be a 7. So there are other ways to do that, but I think in this particular case, that's what I would do, is just say it has to be a 7. 1/3 times 7, it would give you 7/3. I don't remember too many like that. We just go. So what did I say? The answer was 7. Let's see if they're happy. If they're not, whoops. How about that 7? Sometimes they get weird at the end. Let's see it. Okay, so this particular one, at least we don't have silly fractions, but what you're going to do is cross multiply because it's a proportion. So you're going to go what times what? 90 times what?
X.
Yeah, in this case, y. Equal,
Y. Yes.
yeah. What's the other direction? Equals
16 over 126.
times 126.
Mm.
So 90 times y equals the 60 times 126. So we're going to use, I'm going to use a calculator on this, but we've got the whoops, that one. So what we need to do, there's nothing to do over here yet, but we could actually multiply that. So to save time, that's what I'm going to do. Whoops. 126 times 60. So this is 7560 equals 90 times y. We want y. So here's y. We need to get rid of the 90, multiply by 90. What do we do to both sides?
90.
Divide by 90 and come over here and do the exact same thing. These two cancel and we're left with y equals, and I'm just going to put it in the calculator. The answer is 84. You could do that. I mean, if you had to do it, but honestly, when the numbers get large, I don't mind using the calculator. But if you had to do it by hand and your battery died on your calculator, whatever, I would take out those 2 zeros and then just divide 9 into 756. It wouldn't be that bad of a problem. Okay. So are we seeing how to do proportions? That's the main thing, I guess. You know what has to happen. So the answer was 84. That may be far enough, but let's see. I don't want to get into the crazy problems. Ah, the chickens. Didn't we do this in class about chickens?
Yes.
Yes, we did.
We did. So
Mhm.
maybe this is just a new version of the chicken problem. So the farmer knows that if you have 50 eggs altogether, only 45 could go to the market. So I'm going to write that down, 50 and 45 for the market. Now he has 1,400 total eggs. How much is the market? Everybody write these numbers down. 50 eggs, 45 could go to the market. If the chickens lay 1,400 eggs, that's a lot of chickens. How many would be marketable? So there you are. I'm going to do that one, that one, that one, that one. So I literally, the first sentence, I just wrote it straight across. 50 eggs, 45 can go to the market. Now, they had 1,400 eggs, so I put eggs under eggs. And then this will be market. And so you make your proportion right out of the notes. Technically speaking, the word eggs cancel out, and what's left is what, how many can go to the market. So literally, this is a good proportion, one fraction equal to another. If you don't like messes, then rewrite it. Like that. You don't like it, but it's correctly set up. So you multiply one diagonal, 50 times x would be 50 times x. 1,400 times 45. We can't do anything with this yet, but we can get a single number out of this. So that's my plan. 1,400 times 45. Answer is 63,000. Wow. 63,000. Okay. So when you do these problems on a test, write your work down. Because if I was giving part credit for anything, this is half of the work, getting the numbers in place. Maybe more than half, to be honest, but it's at least half. Then the rest of it's the simple part, 50 times x, one side equals 1,400 times 45. We multiplied that. You locate the letter, you see the number next to it that's multiplied. To do the opposite, you divide. 50 divided by 50. Cancel, cancel, x equals, and I still have it in my calculator, and I'm going to divide by 50. 1,260. That's what that missing number is. What do you think?
Yep.
Now it's 2 o'clock. So the question is, I guess that's probably far enough. Did anybody try to do some problems that they couldn't do? And I don't know if I want to turn off the recording or not. But I think I will.